Web3 is a user-centric vision of the World Wide Web that adds blockchain technology to the back end of the existing internet to create an open, trustless, and decentralized network. The core promise of Web3 is the ownership of one's data and identity, which allows users to manage and monetize their content without the interference of a third party, and also to engage with decentralized organizations, applications, and marketplaces through their digital identities. The market opportunities for Web3 span the financial sector to the art world and are reflected in the exponential rise in the number of active Web3 developers and the billions of dollars locked in DeFi smart contracts. However, vulnerabilities and technology challenges are hindering the broader adoption of Web3 applications, including those in a $500 trillion private assets market. Security and identity are inflexible, scaling solutions are immature, and the integration of blockchain with legacy technology is more of an afterthought than a deliberate design decision. The Accumulate protocol is a layer 1 blockchain that was designed around the needs of enterprise users. Its internal architecture scales linearly with adoption, and its throughput is high enough to support payment rails, IoT networks, and high-frequency trading platforms. Most importantly, the identity and security infrastructure of Accumulate is flexible enough to meet the dynamic needs of clients and to adapt to the evolving Web3 ecosystem. An organization's structure can be modeled as an interactive and dynamic hierarchy of identities. For example, a large company may have branches, departments, employees, and clients whose tasks may change over time. These hierarchies are difficult to reproduce on the frameworks of most blockchains because they are organized around transactions and constrained by blocks. There is no Accumulate blockchain per se. Rather, each identity in the Accumulate network is treated as its own independent blockchain and assigned to a small subset of available validator nodes that we call block validator networks, or BVNs. This allows the network to be partitioned by identity and scaled to millions of transactions per second by adding more BVNs. Identities on Accumulate are human-readable, URL-based addresses that we call Accumulate Digital Identifiers, or ADIs. URL addressing facilitates the integration of Accumulate with websites and mobile apps, while human readability minimizes human error and allows data to be intuitively organized in the same way that files are organized into folders and subfolders on your computer. The components of a hierarchical organization can be represented on Accumulate by top-level ADIs and nested sub-ADIs. For example, the ADI bank may be associated with sub-ADI branch. Responsibilities are represented by the various accounts that can be managed by each ADI and sub-ADI. For example, data accounts, token accounts, or staking accounts. Both ADIs and sub-ADIs can also be managed, updated, and exchanged to provide the flexibility needed to adapt to the growth of an organization. An organization's security can be modeled on the blockchain as an interactive and dynamic hierarchy of signatures that are backed by cryptographic keys. For example, important decisions that require the input of multiple people may be reproduced in a multi-sig transaction whose execution requires n signatures from n permission signers. However, the current security paradigm in blockchain is defined by authorization schemes that lack the flexibility demanded by enterprise applications. An asset may be irreversibly lost if keys are lost or compromised. Complex operations that automate security, that modify the rules of a multi-sig transaction, or delegate sign-in authority are difficult or expensive or maybe even impossible to manage on other blockchains. Key management is possible on Accumulate because security is organized into a hierarchy of keybooks, key pages, and keys, similar, at least in structure, to how identity is organized into ADIs, sub-ADIs, and accounts. Keybooks are top-level authorities that tell you which ADI is involved in the transaction. Key pages are organized by priority, which gives higher priority key pages the ability to make changes to key pages of lower priority. Keys are used to sign transactions, and their number and ownership within the key page can be modified. Overall then, the ability to manage your keys enables features like key recovery, key rotation, and key backup, which are all needed by enterprises to protect their assets and adapt to changes.